Hello smart mathematicians, let's do question 10. In the diagram alongside ABCD represents a closed door. This is ABCD, the shaded part. That's a closed door, which is 1,2 meters wide and 2,2 meters in length. When the door is open, 42 degrees along its hinge, we have our angle here, 42 degrees along its hinge AD. Its new position is represented by AEFD. So we have AEFD, which is still the same door, but now it's opened. Okay. Determine the size of angle FAC. So we want the size of this angle. Right. What can we do here? Let's look at what we're given. So we have AB, which is 1,2, AD, which is 1,2. A door is a rectangle, meaning that BC is also 2,2 meters. Let's just fill in the information as much as we can. That means that AE is also 1,2 meters. It's just the same door. And then DF is also 1,2 meters. All right, DC also is 1,2 meters. EF is also 2,2 meters. Right. So we want angle FAC, which is the angle of this triangle. This is a triangle FAC we're interested in. Is it possible to get the size of this triangle? Can we get AF? Can we get AC? Can we get FC? Right. If you check, AFD is a right angle triangle. AFD is a right angle triangle. This is a right angle. Even this one is a right angle. We can find side AF using the Pythagoras theorem. We can also find the side AC. Actually, side AF and AC are equal. So if you find AF, then we found AC because they're just equal. We can find AF using the Pythagoras theorem, right? And then after finding AF, it will be the same as AC. How can we find FC? How can we find FC? Right, FC, we can use the cosine rule. We can use the cosine rule because we have two sides and an included angle. So we can use the cosine rule here. But if we want to use the sine rule, we'll need to get these angles first. I'll show you also how to use the sine rule. We're going to get angle DCF and angle DFC. And then we can use the sine rule to get CF. Let's start by finding AF in triangle ADF. See triangle ADF? ADF, right? We can say AF is the hypotenuse, so AF squared is equal to AD squared plus DF squared. And then the reason we say Pythagoras. And then we can find our AF, can put this in the calculator. AF is equal to the square root of 2,2 squared plus 1,2 squared. And then which is equal to 2,506. Meaning that AF is 2,506. We say that AF is equal to AC. Meaning that AC also is 2,506. So now we need to find CF. We need to find CF, so we can use triangle DCF. Let's use this triangle DCF to find CF. Let's use the cosine rule. CF squared is equal to DF squared plus DC squared. So it's going to be 1,2 squared plus 1,2 squared minus 2 times 1,2 times 1,2 cos 42 degrees. That is CF squared. And then CF squared is equal to 0.7397 units. Then you can find CF. CF is equal to 0.86 units. So this one is 0.86. Let me show you the other method for finding CF. We said we can use the sine rule. So we can get these angles DCF and DFC. If you check, triangle DCF is an isosceles triangle. So we can say DCF is equal to 180 degrees minus 42 degrees divided by 2. Angles opposite equal size. That's the reason we write there. Angles opposite equal size, and also sum of angles in a triangle. We're using those two. Right? And then DCF is equal to 69 degrees, meaning that DFC is also 69 degrees. So this is 69 degrees. This is also 69 degrees. And then now, using the cosine rule, you can say CF over sine 42 degrees is equal to one of the sides, 1,2. Let's say DF, which is 1,2 over sine 69 degrees. Then CF is equal to 1,2 times sine 42 degrees over sine 69 degrees. Then get that CF is equal to 0.86, which is this. Right. Now we have the side CF. Now let's go back to our triangle AFC. Right, we're going back to our triangle AFC. We're going to use the cosine rule. We have three sides. So to find the angle here, we have to use the cosine rule. So remember that CF squared is equal to AF squared plus AC squared minus 2 times AF AC cos FAC. So now we want angle FAC. So you can start by substituting your things, or you can make cos FAC the subject of the formula. It's your choice. You can start by substituting here, substitute your things, and then later find what? Your cos FAC. Or you can make cos FAC the subject of the formula. So let's make cos FAC the subject of the formula. So we can say, if you bring this one this side to the left, becomes 2 AF AC cos FAC is equal to, and then we bring CF squared to the right, becomes AF squared plus AC squared minus CF squared, right? And then one cos FAC, let's say, and then cos FAC is equal to AF squared plus AC squared minus CF squared over 2 times AF times AC. Right, if you can remember this formula, it's still okay. Or you can even substitute here everything, and then you find your cos FAC. Okay, right, let's substitute everything. So it becomes cos FAC is equal to AF is 2,506. AC is also 2,506. So it's 2,506 squared plus 2,506 squared, then minus CF. We got our CF here, 0,86 squared over 2 times AF 2,506, and then AC 2,506. Right, you can put this whole thing in the calculator. Then cos FAC is equal to 0.9411149,872. Then angle FAC is going to be arc cos 0.9411149,872. And then put this in the calculator. You find that your angle FAC is equal to 19,8 degrees. That's the answer.